Okay, last word problem that we're going to do on this page, and then we might do a couple other bonus problems. So number 3 says the product, immediately we see this word product, and that word product means multiply, right? Or answer to a multiplication. The product of 3 more than twice a number and 1 less than that number is 18. Find the numbers. Actually, this is already going to be factored, but I mean, we'll have to factor again because we have to set it equal to 0. So if we don't know what the number is, we're going to use a variable. A lot of times we use x. We're going to say x is the number. What I've done here is I've defined the variable. Okay? So now expression number 1, 3 more than twice a number. How do I translate that into math? 3 more than twice a number. 3 plus 2x. Okay? There's one of our factors because we're multiplying to get a product. 1 less than the number. What's 1 less than the number? How do you write that? X minus 1. Very good. Is 18. The product means we multiply these together. 3 plus 2x times x minus 1 equals 18. Now, it might confuse you, this order, so you could always write this as 2x plus 3 and x minus 1 equals 18. Because usually when you FOIL. Now, can I solve this? Can I say, well, this equals 18 and this equals 18? No, because 18 times 18 is not 18. Right? The only number that will work here is if we have it set equal to what? 0. So we need this to be 0. Now, if I subtract 18 from both sides, is that going to work right now in the current form that it's in? What do you need to do in order to be able to subtract? Because you want to be able to set equal to 0. In order to subtract 18 from both sides, what are you going to need to do to this side, do you think? Yes, you would FOIL it. You would FOIL it because right now I can't subtract 18. These guys are in parentheses, right? They need to be multiplied. So if we FOIL, we get 2x squared outside negative 2x, inside positive 3x, last negative 3, and then also we're going to have the minus 18 so we can set it equal to 0 since we're doing this. We're subtracting 18 from both sides. This is the same negative 18 on the other side, okay, because we're going to subtract 18 from both sides, but we had to FOIL that out. So now help me simplify. What are we going to get when we simplify this all down together? 2x squared plus x minus 21 equals 0. Okay, now I'm running out of space, so I'm going to go on to other paper. So make sure you're carefully transferring this over. 2x squared plus x minus 21 equals 0. Be really careful about this. It doesn't hurt to just check over your math again and make sure you did it all right. Okay, because if you didn't, you'll get the wrong answer and it'll be kind of frustrating. So let's go on to factoring. Now that it's set equal to 0, what should we do to solve for x? In order to solve for x, we need to, yes, we need to use the AC method in order to factor. Okay, we're going to factor because it's set equal to 0. So AC method is going to be A times C is negative 42. Can you think of two numbers that multiply to negative 42 that add to what? What's the sum? Sum equals 1. Negative 6 and negative 7? Is a negative times a negative give you a negative? Oh. And positive 7. Oh, do you see how we fix the signs? Everybody clear on that? So we're going to use the AC method. What do I do next? Now that I know my factors equals 1, right? These add to 1. What should I do now? Minus 6x plus 7x, because notice that these two numbers add to 1, right? So I'm not changing the value at all. I bring down the last, I bring down the first, I split the middle. Okay, now what do I do? Group. Group the first two, group the last two. What's the greatest common factor in the first? 2x, and what gets left? Good. What's the greatest common factor of the last two? 7. Positive 7. Now notice I'm going to put that positive sign there. That helps when it comes to factoring, right? We should get x minus 3. If we did it right, we will always have this be a match. Why is it important that these two factors match? Because we're pulling it out, right? Remember, this is the greatest common binomial factor, and this is what's left. 2x plus 7 equals 0. Okay, now the difference between factoring and solving. Right now, this is currently factored, but we want to solve. So what do we do to solve? We go x minus 3 equals 0 and 2x plus 7 equals 0. We solve for x. Plus 3, x equals 3. Minus 7, 2x equals negative 7. Divide by 2, x equals negative 7 halves. Now, if I go back to the original equation or problem and I read it, the product of 3 more than twice a number and 1 less than the number is 18. Find the number. So, wait, what are the numbers? The product of 3 more than twice the number. So the number could be 3, right? 3, and then if we plug that back into, where was the equations we wrote? Hmm. 3 plus 3 times 2. So 3 plus 3 times 2 equals what? 6, 7, 8, 9. And 3 minus 1 is 2. What's 9 times 2? 18. And usually we say integers here, but this is a fraction here. We can use the fraction one as well. 3 more than twice negative 7 halves. What's this equal? The 2's cancel. What's 3 plus negative 7? Negative 4, right? And negative 7 halves minus 1 would be? It'd be, this would be 2 over 2, right? Negative 9 halves. If we have negative 9 halves times negative 4, will this equal 18? Oops, I'm off the page. Does that work out? Negative times a negative is a positive. 2 goes into 4 2 times. 2 times 8, 2 times 9 is 18. So that would be our check, right? Now another problem came up that's very similar since I haven't gone too long. I think it's a related problem. So let's say we had a rectangle and we wanted to find the area. How do you find the area of a rectangle? Length times width. Okay. Let's say the width is W and the length is W plus 4. And the area, let's say I know the area is 45. What's the length and what's the width? What is the length and width? Okay, so can we set up an equation to solve here? And this might be something like, you know, the length of a rectangle is 4 more than the width. The area is 45. Find the length and the width. So what would be the equation that I could write here? 45 is equal to W times, right, because here's the area, here's the width, here's the length. Oh, so I'm just still using the formula area equals length times width. Okay, now how do I solve this? I want to solve it algebraically. So when I solve it, I'm going, in order to subtract 45 from both sides, what do I need to do with the W and the W plus 4? Distribute, right? 45 equals W squared plus 4W minus 45. Why are we subtracting 45 from both sides? Yes, we want to set it equal to 0. Now what do we do to solve? Yeah, or we factor. W times W gives you W squared. We don't really have to use the AC method when the A is equal to 1. Can you think of two numbers that multiply to negative 45 that add, that have a sum of 4? 9 and 5, which one should be negative? Positive 9 and negative 5. What would be my W's then? What is going to add to 9 that gives you 0? Right? What's going to subtract from 5 and give you 0? W equals 5. Now, when you think about a rectangle, I have two different answers here. Can I have a rectangle that has a width of negative 9? How have you ever drawn a rectangle that has a negative width? No. Could it have 0 width? If it had 0 width, what would it be? Not a rectangle, right? Not a rectangle. If it can't even have a 0 width, it can't have a negative 9 width. So what we call this is an extraneous solution. It's a solution to the equation, but it doesn't make any sense in the context. So the width has to be 5. What's the length have to be then? If the width is 5, the length is 9. You see that? Because if you did really go negative 9 times negative 5, you would get a positive 45. So it works out mathematically, but the only answer that makes sense is the positive answer. So for problems involving time and an actual geometric figure, you would exclude the negative answers. You'd still get those two valid answers. It's just only one of them actually makes sense. Does that make sense? One of the answers makes sense and the other one doesn't. Yeah. And the same thing that happens with time. If let's say I threw a ball, right, from the top of a cliff. What's going to happen is if you solve for when it hits the ground, you'll get a negative answer, time equals negative 2 seconds, and time equals positive 10 or something. Again, we exclude the negative answer. Yeah. You can't have negative time because you're not Michael J. Fox and you don't have a time machine. You don't have a DeLorean. If you did, you could go back in time. But we always exclude negative time. I mean, a lot of times students will get confused because they think, oh, all the time I'm going to exclude a negative answer. No, the negative answer exists on the graph. It just doesn't exist in reality because we don't consider negative time. We don't consider negative distance, you know? Okay. Very good. We'll stop this.